I'm Roberto Polli from Babel, and I'm going to tell you a Python story. It's a story about even if you're a Python noob like me, you can even contribute to a project and get your patches accepted. In a very few time, I think it took more time to make the slides than to make the patch. And you just have to use some tools that the Python and the open source environment gives you. Before starting, I'd like to thank my colleague Fabrice Gras, which is a great Samba expert, and Babel, which is the proud sponsor of this talk. Babel is an Italian IT company which delivers large mail infrastructure based on open source software for various Italian internet service providers and public administrations. So, open source is popular. People love open source because it's free as in beer. But why people is afraid of contributing? Well, we are a few people, so I'm going to ask to you, in your opinion, why people doesn't contribute to open source? Okay, that's true. So he says because they're afraid to be criticized. Yeah, because many companies thinks that it's costly. They are spending money, but it's not useful because their work won't be accepted and introduced. And some people, because they is not confident that their patches are good, so to be criticized. We see in our experience that using the good tools like GitHub, social coding, and simplifying testing processes, you should be very less scared. You don't have to be afraid because tests will guarantee that your job is right. And moreover, that you don't have to be a guru to support open source. So after watching something about GitHub and node testing, we'll see how to create a simple C extension. How is made the Samba client library, and our story, which is simple. We cloned the project, and while cloning, we got in touch with the maintainer. This is crucial. Then we wrote test firsts. Then we extended the library, wrapping two functions already present in the standard library, in the standard C library, and added our feature, which is enable PySmbC to support Windows access control list. The nice thing here is that we don't need to know SMB, which is the protocol underlying Samba, to extend PySmbC. We just had to learn the API exposed by the C library. So let's start with GitHub. Open source coding is not just a technical stuff, it's a social stuff. You can be a really good technician, a wonderful programmer, but if you don't learn to be relational, your patches won't be accepted. Don't know if you remember MOSFET. He was a famous good developer of KDE. Many patches he made will never be accepted into the main tree, and he made a fork of part of the interface of KDE. That's one of the reasons, because getting social is important. In the elder days, how could you contribute to a project? Do you remember? I think somebody here? Well, okay, the man with the black hat. How do you contribute to a project in the elder days? Okay, it was quite a hell. I maintain a small Java library, and it's still on SVN, and I got a lot of patches, and I have to tell people, hey, please, your patch is fine, but please use the trunk one, because if you give me a patch to a tagged release, it's no more useful. Even I got many patches of different branches, and I have to make a lot of work and a lot of headache to get things together. Well, that was the 1.0 hell. Coding 2.0 is simple. It's fork me on GitHub. Maybe the man with the black hat would ask, did you say fork? Fork was the nightmare of every open source maintainer. Forking means fragmenting the user base of an open source project. In the first image, we've got a red main line and a lot of forks. And what we have is sparse writes, increasingly merge efforts, and a lot of lost changes. GitHub works like the Linux I/O scheduler. It helps to merge writes. So the fork approach of GitHub is the second one. It's not just like fork, but continuously merge forks. So GitHub tracks forks for us and then help us to push changes to the master. So, well, in the first image, we have a cascade tree, just always, the number of trees is always increasing. In the second model, we have some, those are false trees because they're just like streams that sometimes rejoin to the master or between them. So the number of forks, of real forks of different codes, tends to decrease periodically. This will make your maintainer happy, and well, that's good. Those are some GitHub features. You can, after you have forked a project, you can patch and commit to your repository so you don't lose your changes. You can track your own history. Then you can, if you fork one of my projects, you can push back your changes to my repository. So no more mail with patches, no more unsynced versions. And moreover, I get the change history. So I can check your thought process, and maybe I can merge partially your job. And this is a really nice feature. GitHub portal supports code annotation. So you can discuss on GitHub about patches and about code. And so before merging a patch, you can maybe refuse to a patch, but discuss with the submitter and tell, why did you do this thing in this way and not in that one? And another nice thing is the ability to merge with different repositories. So this is GitHub was an enabling technology that let us keep in touch with the maintainer, don't lose our changes, continuously tracking our job. Now enters PySmbC. Everybody knows about Python C extension. If you got a C library and you don't want to implement it from scratch, you can wrap it with Python, and so you get some advantage. You enjoy a stable C library. You have to just manage input, output, and errors, and the result is usually faster than a pure Python implementation. Here is a small example. Let's imagine we have got SMBC in our Python pet. We use IPython. Everybody knows IPython. It's a nice console that supports GNU read line. And we just imported the library just if it was a .py and print some constants or use just some functions that we have. Oops. Okay. So let's start with an example. Imagine we have got a small factorial function written in C that is based on long integer. It is 64-bit integer. So what shall we do? We create a robotfile.c, which is the source of our extension. We create a myFactorial function which parses and validates the input, calls the Robin function, and return a Python object. So simply, here is the Robin function, call the Robin function, and return a Python object. Moreover, we get a structure to map Python methods, which is factorial, to the C rapid function, myFactorial. Then we build it and import and play. So it's really simple. But you have to be careful. Parsing and validating input and output is crucial. We don't want to introduce buffer overflows, inconsistent behavior, segmentation fault, or memory leaks in Python because we are loading a shared library. So the first thing to do is parsing and validating, eventually creating new exceptions in the initialization function, and then, in case of error, throw exceptions in the function. Throwing an exception in a C module is just like it is done in C. In C, when you write a function and you want to support the errno, you just have to blank errno, call a function, and set the errno variable, and then return. For example, -1 in case of error. Then the user have to know that if the returning values of the C function is less than 0, they have to see the error variable. Then here in Python is similar, but is different. You have to set the PyR variable, which is just like the errno, and when you return null in the C code, Python will throw an exception. So let's see the rapid function. The myFactorial gets some arguments. They are validated by parse tuple that is looking for an integer value. It's an I, not a D, just like printf. If the variable given is not an integer, we are just returning null. But Python will throw an exception because the PyR is set in parse tuple. Next time, we are using a factorial function returning a long integer, which is 8-byte. So, which is the max value supported by an 8-byte integer? Is just like a number with 18 zeros. And which is the largest factorial that fits 18.0 is 21. So, because the rapid function gives meaningful results only for n for input lower than 21, we check it in the function, and in case of error, we set the variable and return induce an exception. We define the exception even in the module, and well, in the init function, we state that the fact error is an exception. We could have named it underscore wrapper dot factorial too large exception. That is just a string. Is it clear? Questions on that part? Okay.
The name of the exception, if I want to return value error, stuff like that.
Yeah, you instead of using fact error, you have to assign fact error to pyx underscore value error. So you just have to use a different function to throw value error, for example. In many cases, you may want to track the C-erno variable. So in some cases, you will write a function that is just like set from error, pyr underscore set from error. In that way, you can track what's happening. So, just try to put things together. Which are the C extension components? Exceptions or constants or whatever you want to pass to the module. Functions, wrapping functions. Function method maps. So, something which ties together the name of the function and the function to call. And the init wrapper method, so the init module method. Function and exception should be static because, well, you are not going to call them from another C. And if you do something with memory, if you free, well, even if you declare exception, you should tell to Python that not to remove those constants, for example, fact error, fibo error, from the Python stack. So for going deep, you just have to read Python documentation. But if you're comfortable with C, it's quite linear. Okay, the initialization function. So we have write our C extension, which could be or not to be a module. But we can even enjoy Python code. How? Simply wrap, again, the C extension in a Python module. So we got our factorial library wrapped by the wrapper.so and even wrapped by a Python module. In the init.py, we import helpers, which is a Python file, and then import all methods that we defined in the extension. Again, for MyPython, we can use all the stuff. So, nodes, let's contribute. Okay, now we learn how is made a C extension, but before adding features, we had to check the project status. So we cloned the project, set our Samba environment, the server, and then just wrote 2 words, nose test test. Nose test is a Python script that auto-discovers and runs all test cases. It supports even tests written with Python unit test. Important thing, even when you use libraries, is to add new feature only after successful tests, because you have to ensure you're not breaking anything. Moreover, verify and agree with your maintainer about the test environment. For PySmbC, you need, for example, some Samba shares with various permissions, and for our tests, we have to mess with extended access control list. You may need 2 or 3 users, various groups, and when you play this, you have to document the environment needed to play successful tests. So it's easy, but I see that not everybody is tidy with those things. On successful tests, we start developing. Following the Git way, we created a separate branch that will merge on success. I made this one. Check out iocstream_set_etc. So this name helps the maintainer to know who is making the change and which changes are going to be made. Again, test first. Write the test before writing the code. In this way, you'll be more focused on target. Writing tests is not just verifying that you are going to do the right things, but even planning. Writing tests is just planning a schedule on your project. So with no tests, you really have no reason not to do it. So this is the standard unit test way, and on the right side there is a nose test. The difference is seemingly on the last part. No script will have to discover the script named test_script. So with nose, you just have to name the script just like test_something, and it's by default a test. But so if you use it to unit test, you can shift nicely to nose. But it's even simpler. So you're in a hurry. You don't need to import nose or define a test class. Just do a setup and tear down and your test. In this case, beware, setup is run once for all tests. So setup, all tests, tear down. If you want to run setup and tear down methods before and after every test, you have to use the former way, so the class way. Again, no supports annotation. So don't use setup and tear down, just like pre and post methods. Decorate your test with setup, pre and post. You can use different, obviously, methods for setup and tear down. And in using this annotation, you can skip the class stuff and just add with setup and tear down are run always before and after every test. You can skip this test if you, for example, want to commit the test before you have done your patch. You can tell the maintainer, hey, I added this test. You can merge them, but they are skipped. So if somebody check out the project and run the test to see that if everything is fine, well, everything is fine because this is not done yet and knows it have to skip. How can you run nose? Straight on with the path, with the name of the file, using a single method, a single test, using a class, changing the work directory of the test with -w. And if you want verbose output, just like add S and V. Nose tests usually silent tests, so you just see 1 dot for a successful test, and S for skip, and F for fail. If you use S, you'll print out all the print statement that you put in your tests. So, and we are going to close here. We started adding the get exact feature. So knows and ensures that everything we have done don't impact on existing features. We started writing tests. Those tests are quite simple. Tests that our constants are fine. Tested that the methods and works for all valid attributes you are going to pass. And another, test the behavior with bad values. This is important because we are going to pass something to C. And if the input is malformed, you have to check that you don't get a segmentation fault, a buffer overflows. But the nice thing is that your test is written in Python. Well, in our case, I'm catching for this test a runtime error. In the next release will be a value error, just like it states. But even throwing a value error, I get the error variable from C, because I like to check that the behavior is consistent with the C library I'm going to invoke. Once you've done those simple lines, you just have to code until tests are successful. The great job is just to find an agreement with the maintainer about tests. If the maintainer agrees with your tests, he surely merge your patch and include it in the branch. This is the last slide, adding the static attribute and features. And well, actually, the Samba extended attribute are quite complex and are strings. They are made of various parts: revision, owner, group, and various ACL. To play with that, the best way is to use Python, because Python is very nice in managing strings. So now I'm working on passing class and to map all those hexadecimal values from the Windows code to something more readable and usable from Python. Well, to play these, I had to, excuse me. I had to modify the library behavior, because as of now, SMBC is just a single .so file, while I made a shift. I created a directory, put on the helper class just like we saw in the first slide, so that we can write the helper class to manage ACL. The tests are quite similar to the former one. And now I'm discussing with the maintainer about this shift, because, well, this library is included in various distributions, and he wants to be confident. Again, on my side is the test directory is the same. The tests are the same and are still successful. So I'm confident that even if I change and remix everything, the behavior of the library for the user is still the same. So here, this is the end of the story. It talks, again, more to make the slide than to make the changes, but I wanted to share it with you because, well, I was, and I'm still really a Python noob, but in a really few time using those patterns and those tests, I was able to contribute. So you, the Python guru, really have no excuses for not contributing to such projects. If you want to learn something about PySmbC, you can fork me on GitHub or look at the stable version that is one step and a half behind. If you're curious about Babel, or you can watch something about Linux system, Java, C, Python. You can watch out our company blog. And well, thank you. Excuse my English. I'm still learning, and hope I've not been so boring. Okay, that's fine. If you have questions, or if you want to see some code, well.
Okay. Yeah.
So thank you for the nice talk. I have a question. Do you hear it? No? Yes, okay. About nodes versus a unit test. While I see that nodes has great advantages compared to the classical unit test package, but with Python 2.7 we got the unit test 2 package, and it seems to me that they are quite equivalent. Do you know relevant differences? If there are still relevant differences between the modern unit test and nodes?
Well, actually, nodes can support tests written with unit tests. If I don't mistake, when you install nodes, you should have installed unit tests before. So it's just a way, it's just a tool that enables you to run tests in a simpler way. One thing is that if you, for example, if you use Eclipse or any IDE that supports unit tests, and you write the simplified one with nodes, probably it doesn't work. So if you use something like Eclipse that are or any ADI that has some extension made for unit tests, you should stick with unit tests. But anyway, you can run it with node tests. So if you have to run all tests into a directory, you just go straight with nodes.
Any other questions?